All right, guys, I'm going to go over these area models so you kind of understand them a little bit better. So I'm going to start with this one. With the x squared plus 6x plus 5. If we're thinking about this, we know we're going to need an x squared, 6 x's, and 5 singles. If you remember from previously, okay, the design of what goes where in our rectangle, this area, okay, is always your x squared area. Okay, this is always where your x squareds are going to go. Okay, these two areas are where your x's went. And the last area is where your singles go. So when you're building these rectangles, keep that in mind. We always want to have that kind of structure happening in order to accurately place these. So if I'm trying to just like brainstorm a couple things, I might start with putting this here and putting my 5 singles across like that. Okay, so that they're in the proper corners. Again, you can see if I divide this up into my 4 pieces that I've got my x squared in the top left and my singles in the bottom right. My x's are going to go somewhere in the other 2 spaces to build an entire rectangle. So I'm going to put those in there where they make sense. To me, it looks like we obviously need 5 here to match the 5 dots, but we also need 1 here to build the rectangle. If I were trying, this would be the correct orientation of everything. If I were trying to do this and I tried to place this green one over here, it no longer is a rectangle because we've got holes in certain places. You can see holes. You can see holes here where there's nothing and here where there's nothing. Okay, so we've got to make sure that this is an exact rectangle. So I'm going to get it back to its correct orientation. Let's get it like this. So now you've got to ask yourself the question, okay, what did I multiply? What is the length and width of this rectangle based on our algebra tiles that we've been working with the last day? So up here, this is x, right? So because that's the length of that. And then up here is 1, 2, 3, 4, 5. 5. So this is x plus 5. And then if I look at let's call that the length. If I look at the width, I've got the width of that square is x. And then I've also got that single one that's going to account for that. And you can kind of check yourself, right? X times x is x squared, right? X times 5 is 5x. X times 1 is 1x. 1 times 5 is 5. So you can kind of see your pieces matching up. So my factored version of this is x plus 1 times x plus 5. One way to check and see if you're right is multiply those back out. See if you actually get the values that we started with. As far as coming over here to the generic rectangle, as what you guys would like me to call the box, we can come over here and transfer the same information. So we've already built our rectangle. We know x squared goes here. We know 5x goes here. We know 1x goes here. And we know 5 goes here. So we can actually pull out those GCFs, greatest common factors, vertically and horizontally, to actually find those same values over here algebraically. So this is what I'm talking about. So like if I look at this vertical column, right, and I ask myself, what do they have in common? What could I divide both of those evenly by? Well, the answer is x, right? And so that makes sense that it would be our leading term for one of our factors. And then I can keep going, right? So like over here, if I have my vertical one on this side, the biggest number I can divide evenly into both of those is 5, right? Specifically a positive 5, just trying to be specific. Then I can go and look at my rows here. So if I look across this row, right, my GCF is X, because X is the biggest thing that divides evenly into both of those. And if I go across my bottom one here, my bottom row, you might be asking yourself, Miss Fi, I can't think of anything that goes into those. Well, 1. 1 always goes and divides evenly into those. So that would be, again, another representation of how you can show me that those are the factors. X plus 1 and X plus 5, when I multiply them together, should give me X squared plus 6X plus 5. So let's look at another one now. Oh, I hate that that does that. Okay. Let's erase. So this one, we've only got 2 terms, which means that ultimately you could write like plus 0 here if that helps you, because it kind of helps you see that what's going to happen is that they all end up going into 2 spaces rather than all 4. So I'm thinking about this, and I know I'm going to need 1, 2 of those, and I'm going to need 1, 2, 3, 4 of those, right? And I need to organize them into a rectangle. Again, thinking about the structure, knowing that your blues are going to go up in the top left. There's my 2x squared. And I know my reds are going to go somewhere, right? If I try to do this, like split them evenly, like let's say I did that, the problem is that now we've got this big open spot and no actual digits to put into it. It doesn't build a rectangle. So that's not going to work. So instead of putting them down here, I'm actually just going to run them over here, because this does make a rectangle. When I don't have those single digits, it actually kind of makes it easier to make a rectangle. And what you're going to see is that means that your bottom 2 boxes are empty. There's nothing there, okay? So if I'm thinking about actually what does this make when I'm looking at my factors, like what values what are the length and width of my rectangle? This is X, this is X. So this is indeed 2X. And then over here, I've got 1, 2, 3, 4, minus 4. So that would be one side. And then this side would be X. So my factors are X and 2X minus 4. I can do the same thing over here with my generic that I did before. I'd have a 2x squared and a minus 4x. In this case, I'm leaving this box empty. Or if you really, really want to write it out, you'll see you're going to get the same thing if you put 0x and plus 0. Now look at this GCF work. What's the biggest thing that divides into 2x squared and 0x? It's 2x. What's the biggest thing that divides into negative 4x and 0? It's negative 4. These have an x in common. These have a 0 in common. Right? And double check by looking inside your boxes. 2x plus times x is 2x squared. Negative 4x times x is negative 4x. I'm sorry, negative 4 times x is negative 4x. And then the 0 makes these cancel out. All right, let's look at another one. So this is one where it starts getting a bit challenging, and you've got to start thinking about 0 pairs with your x's. So with this one, I'm thinking about x squared. I need one of these, and I need 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what I need to put in there. The problem is I'm already thinking about my structure, right? And my generic. And I know that my x squared's got to go here. And I know that my 9 have to go here. Guts tell me to go ahead and put those 9 into a square, because that does indeed help me build this rectangle. Since it's an odd number, I'm not going to be able to make it into anything better. So you'll notice that these are empty. These spaces here are empty. That's a problem. We're going to need to actually build this into a rectangle. So the best way to do that is to have 0 pairs. So in one of the videos it talked about that, where like you're allowed to add one of these and add one of these at the same time, as long as you add them in pairs, because you're not changing what the equation is equal to, right? Because ultimately when you add these up, this is 0. So I'm going to start adding these in pairs and hoping that I'm building a rectangle. And I think it'll be pretty intuitive once you start doing it. So like if I put one here, I'll put one here. I'll put one here. I'll put one here. I put one here. I'll put one here. And you can see that that has indeed built a rectangle. The other thing to think about as you're doing this is notice that everything in the upper right is all green and everything in the lower left is all red. You can't mix colors in a single box. A value is either positive or negative, because when I come over here and write what I've written down, right, this needs to be logical. I can't have something that doesn't make sense where I've got positives and negatives mixed up. So if I'm looking at the length and width of my rectangle, this is X. This is X. This is, right, if I had my pieces up here, this would be +3. And this one would be -3. So my two factors are X +3, X -3. Okay, if I go back over here to this other one and I start thinking about my GCFs, right, vertically, the thing that divides evenly into both of those is X. Same thing on the right side. We've got the biggest thing that divides evenly into both of those is 3. On the tops, biggest thing that goes into those is X. On the bottom, it would be a -3 because they're both negative, so the GCF would be -3. And again, that corresponds directly to our area model. All right, so we'll do another one. This time we've got a 2x squared minus x minus 1. So I'm going to start with what I know I need. Why is this thing doing this? I don't want to do anything with it. Stop it. That's not what I wanted to do. Undo, 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 undo. Yep. You just go away. Okay. So for this one, thinking about my 2x squared, 1, 2, right? I know I need a -x, and I know I need a -1. I'm starting to think about, organizing my boxes here. I know I'm going to need my 2 blues to go up in the upper left, and I'm going to need my 1 red to go into the upper bottom right. It kind of works the same thing over here, right? I can go ahead and identify where those are going to go in this box. Then I've got to figure out, okay, what's going to build my rectangle? Right now I've only got 1 red. So I know, like if I did this, right, that's not enough, because I would need, I can see my empty spaces here that I could fill out with a 0 pair. But this breaks that rule of having different colors in the wrong spot, so I might have to shuffle some things around. As I'm looking at this, I've got a red and a green in the bottom left and a red in the top right. The red by itself in the top right is not an issue, but the red and the green together are. So there's a quick fix to that. If we just make this one red and this one green, now we're not breaking the rules, and now we've got a rectangle that works, and we can identify the length and the width. So here's my X, right? So I've got 2 of them, and then this would be a 1, so it'd be +1, and then here's an X, And then here's a negative 1. So if I was going to write what my factors were, it would look like this. Going back over to the generic model, right? I've figured out that this value is 1x. This value is negative 2x. If I look at my vertical, I'm going to say that my GCF is 2x. If I look at my vertical on the right, I'm going to say it's 1. Horizontal is going to be x. Horizontal on the bottom is going to be negative 1. And that's exactly what I've written down below.